The first phase in the triple jump is the approach run. This is where the horizontal speed is built up in order to have a large amount of momentum throughout the rest of the movement. The joints used are the glenohumeral joint, the femoral acetabular joint, tibiofemoral joint, and the talocrural joint. Muscles used during this phase, starting with the shoulders, the anterior deltoid, pectoralis major, coracobrachialis, latissimus dorsi, all three sections of the trapezius, teres major, minor, rhomboid major, minor, and the posterior deltoid. These muscles are secondary movers and will only help with swinging the arms during each phase. With the lower body at the hip and knee, the iliopsoas, sartorius, pectineus, adductor longus, gracilis, adductor brevis, rectus femoris, and gluteus medius are also secondary movers as they concentrically flex to pull the leg up, preparing for the next stride. The antagonists of these are the semimembranosus, semitendinosus, biceps femoris, vastus intermedius, and the vastus lateralis. These will also act as stabilizers when the leg is planted on the ground, preventing any hyperextension. The prime movers of this is the gastrocnemius, soleus, vastus medialis, vastus lateralis, vastus intermedius, gluteus maximus, and rectus femoris. These will concentrically contract on the opposite leg, creating the speed for the movement. Joint angles during this movement will move from 61 degrees of motion to 161 degrees when extended, with a maximum speed of 10.64 meters per second. In the hop phase, the right leg will push off and then land all in the same phase. Some of the muscles listed before, like the psoas major, iliacus, sartorius, adductors, and the tensor fasciae latae, are secondary movers again, flexing the leg vertically, creating vertical momentum. The prime movers during this is the soleus, gastrocnemius, vastus medialis, vastus lateralis, rectus femoris, gluteus maximus, and the vastus intermedius. These will concentrically contract, rapidly extending the leg to push off the ground. The antagonists are the iliopsoas, TFL, sartorius, anterior tibialis, adductor longus, and the adductor brevis. Joint angles during this will be slightly different from the approach run. The participant's right leg will extend to 174 degrees and flex all the way to 53 degrees, as the left leg will have a range of motion from 57 degrees to 157 degrees. And the whole movement will have a speed of 8.78 meters per second.
The step phase resembles the hop phase, in which he attempts to leap through the air using momentum. However, during this phase, the legs have switched roles. In order for the participant to move upward, he uses his hip flexors as prime movers, such as the psoas major, iliacus, TFL, sartorius, and the adductor group, to bring the femur superiorly. The gluteus maximus and gluteus medius are antagonists. The leg that is momentarily on the ground that he uses to push off concentrically contracts the gastrocnemius, soleus, and tibialis posterior of the lower leg. The vastus medialis, vastus lateralis, vastus intermedius, and rectus femoris of the upper leg are all prime movers. The bicep femoris, semitendinosus, and semimembranosus, and the tibialis anterior are all antagonists. The final phase of the triple jump is the actual jump, where our participant finally lands for the last time. The same muscles used for the previous phases are used for the jump phase on the other leg. The psoas major, iliacus, TFL, sartorius, and the adductors flex the hip to gain upward momentum, and the other leg explodes the body using the gastrocnemius, soleus, vastus medialis, vastus lateralis, vastus intermedius, and rectus femoris. The major difference in this jump is power.
The ideal triple jump, starting from the approach run, should be a fluent running gait until the line, and then a quick push off with one leg during the hop. Then, on each landing, the leg should be near full extension, maximizing the distance gained in each stride. Also, the arms should be fully extended, giving the participant as much vertical and horizontal momentum as possible when going into the final jump.
One of the first things that could have been fixed was our participant's approach run prior to the jump. While approaching the first jump, he performed an extra hop before the first main jump. This pre-hop wastes movement and decreases important speed needed to maximize ending distance. Another issue was found in the participant's arm swing. The double arm swing used was not timed efficiently, which directly decreases its effectiveness. Having a properly timed arm swing will propel the participant further, increasing their jumping range. The last movement he could have fixed was the landing after his final jump. His non-weight-bearing leg either should have extended to mimic striding through the air, or the femoral acetabular joints should have extended posteriorly with the tibio-femoral joint flexed. Then upon landing, flex the femoral acetabular joint and extend the tibial femoral joint to extend the leg anteriorly straight.